Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. We continue our lecture with infrared transform spectroscopy in part 2. Okay, continue with the modes of vibration. Molecule absorb specific frequency that are characterized by the structure. So the matter of the molecule is in terms of the bond vibrate and moving around in either stretching or bending motion. So for stretch motion, it is the distance between two atoms which is either increase or decrease. And bend motion is the position of the atom changes relative to the original bond axis. Now we look at the example of the stretching. We have symmetric stretch and asymmetric stretch. For symmetric stretch, we can see that the bond atom move symmetry in the same direction and with the same frequency. And for asymmetry, it seems like this bond atom is alternately move with the wave number quite higher compared to the symmetry stretch. This one is the example of the functional group contains symmetrical stretch and asymmetrical stretch. This is CH3 methyl group anhydride, amino, nitro. So for asymmetry stretching, it seems like it has more higher wave number compared to symmetrical stretch. Now we look at the bending vibration. Molecule with 3 or more atoms can experience a bending vibration, a vibrational mode where the angle between atoms change. So we have scissoring, the angle between the atom is changing because the way of it bends is different on the type of the movement. For example, this one is scissoring. The wave number is 1450, and for rocking, wave number is quite smaller than scissoring, and twisting, which is moderate value compared to rocking, and wedging. Now we look at the movement of the atom or the functional group in chemical. So we have antisymmetrical stretch. This one move on symmetric stretch, and this one is scissoring bend, scissoring and bending. Okay. So the movement of the atom is depend on the absorption of the atom to the frequency of the infrared. So every atom will absorb different wave number. Okay, this one is the wave number in infrared region. As we can see, no two molecule will give exactly the same IR number. We can see that this one OH or hydroxy group, it has its own specific region, which is lies between the 400 and something, 3000 something, and so on. We have 3000 to 4000 for OH. NH stretching lies between 3000 to 2000 something. Okay, so all this functional group has its own wave number, and the simple stretching, for example, in the range of 1600 to 3500, and complex vibration is lies between 600 to 1400. Okay, we call it as the fingerprint region. So the one at the center here, which is 1600, is a simple stretching. Okay, 1600 to 3500. We call it as a simple stretching. When molecule absorb infrared radiation, the absorbed energy will cause an increase in the amplitude of the vibration of the bonded atom. So light energy will absorb by the molecule in the ground state. After that, the molecule will be start to vibrate and dissipated as heat. The molecule is then in an excited vibrational state. The absorbed energy is subsequently dissipated as heat when the molecule returns to the ground state. So this one is the amount of energy absorbed. Bond strength, we have bond moment and types of vibration of each atom in the molecule. Okay, absorption of the infrared region depends on the molecule and atom inside the compound. So it is depend on the structure of the compound. First, it is related with the bond strength. So bond strength, we have metallic, ionic, covalent bond, van der Waals, and hydrogen bond. For bond moment, polar bond give rise to higher absorption. Okay, polar bond is a compound that have OH structure. And types of vibration, we have a stretching and bending depends on the types of molecule and atom. So bonded atoms will be vibrate first after it absorbs the infrared region, and greater change in bond moment and molecule with stronger bond will produce higher absorption of energy. Now we look at the IR spectra. A plot of measured infrared intensity versus some property of light. So infrared, this one is the example of the graph that you can determine the types of the bond present in this peak represented by the wave number in x-axis versus the percent of transmitted in the y-axis. So functional group area from 3500 to 1500. It identifies the presence of alkane, alkene, alkyne, aldehyde, alcohol, and so on. So fingerprint region is the peak in this part are fairly unique to the substance being analyzed. Spectrum confirm identification which is needed for advanced analysis. So the unit for wave number is 1 over wavelength or 1 over lambda or nu. We call it as nu. As wavelength increase, frequency will decrease and energy will decrease, and also nu will decrease. So if nu or 1 over wavelength is increased, frequency will increase, energy will increase. So now we look at the types of the wavelength and the number of the functional group in each region. So from 2500 to 4000, we can see that the major functional group we can identify presence of OH, CH, and NH group. So we can see this. You don't need to remember this type of bond present because you can refer to the appendix. I will give you the appendix so that you can refer. You just need to find what types of functional group in that structure and match with the number of wavelength presence of that functional group. Okay, for 2000 to 4500, we have alkyne, triple bond, CN, X double bond, and so on. So in region 1800 to 2000, very few bands, and commonly band in between 1650 to 1800 is carbonyl group. And in this region 1550 1650 we have CN and C double C, carbon-carbon double bond, carbonitrile. And in the last region 650 to 1550 we have carbon to chlorine, carbon to oxygen, carbon to nitrogen, and carbon to carbon single bond. So all these have different wave number. Alright, now we look at the functional group and fingerprint region. What is the difference? Two different molecules may have similar functional group. For example, if you have a structure of aldehyde and ketone. Okay, for aldehyde, we have C double bond O, right? Same goes to ketone, we have C double bond O. So it has a different functional group, which is C double bond O. So C double bond O will lies in the region here 1650 and 1800. So means that if you have two different molecules, it can have similar functional group because they have similar functional group, but they will always have a different fingerprint region. So in this course, we will only focus on the functional group, okay, when identifying the structure of molecule. This is because the fingerprint region, which extends from 1450 to 400, is very complex. So for details or advanced measurement or advanced identification, you can use you can use this region for determining the functional group. But for our courses, we just only focus on the functional group region only, not the fingerprint region. Using the fingerprint region, now we want to compare the infrared of propan 1-ol and propan 2-ol. Both these are containing same functionalities, which are OH group, and it also contain CH2, CH, and so on. Both compounds contain exactly the same bond, but both compounds have very similar through in the area around 3000, which is OH group. Okay, the difference between the placement of the OH bond. So for propan 2-ol, the OH bond lies at the carbon number 2, and for propan 1-ol, it lies on carbon number 1 right here. And the structure, you can see that the structure or the fingerprint is quite same, and OH lies here, okay, 3000 here. So compare them in the fingerprint region between 100, 500 to 500. So it's look like a different region here. So commonly the fingerprint region here is the location of the CH, okay, CH, CH3, CH2, okay. So dekat sini dia punya beza dia, the susunan of the CH bond right here is different. Now we look at the transmittant and absorbent. Transmittant is traditionally used for spectra interpretation. So we can see that the peak is downward compared to the absorbent, which is go upward. Absorbent is used for quantitative work. Okay, so you can measure the amount of area below the graph right here. Now we look at okay, this is the same as the previous slide. This one is single bond / triple bond, double bond, and the fingerprint region. So for the fingerprint region, the focus of the advanced analysis. So just focus on the functional group region only. Stretching vibration are typically found in the functional group region. They are the most convenient vibration to analyze when determining the type of bond a molecule has. Thus, we tend to ignore the bending vibration because they are usually found in the fingerprint region. So, if you look at this graph, mostly the fingerprint region, it has a bending motion of atom. So for functional group region, it is mostly the atom will move as a stretching. Okay, so this one is example of infrared absorption frequencies. We have alkene, alkyne. So look at the alkene.